Hey guys, Mr. Dev, and today we're cracking the two-sum problem on LeetCode using Python. So the problem is, we're given an array of integers, nums or number, and a target. So our goal is to find the indices of two number or in the array that add up to the target. So here's an example. Input nums equals 2, 7, 11, and 15. So the target is 9. So the output should be 0 and 1. Why? Because 2 plus 7 equals 9. And those are the indices 0 and 1. So let's write that in code. So our task is to solve this in less than O of n raised to 2 time complexity. To do that, we can use dictionary to store values we've seen so far. Alright, so let's dive into two-sum problem in Python. First, I'll start creating class solution. Inside this, I'll define a function called two-sum. We'll take two parameters, the array numbers, which is nums, and the target value. Next, I'll create an empty dictionary called previous map or prev map. This will store numbers we've seen so far with their indices as the value. Now let's iterate through the array using enumerate. This gives us the index and the number. So inside the loop, I'll calculate the difference between the target and the current num or current number or n. I'll call this diff or difference. Next, I'll check if this diff is already in prev map. If it is, we found our pair. So I'll return the indices of the current number and the matching number from prev map. Or if the difference isn't in the dictionary, I'll add the current number n to previous map with its index as the value. Finally, if no solution is found, which won't happen according to the problem constraint, we return an empty list. But this line is more of a first safety net, and that's it. For I in n in bold enumerate. Sorry guys, enumerate. Sorry. I think that should work. Yep. So, ang runtime natin is 0 ms. So, here's how it works. As we loop through the array, we calculate the difference between the target and the current number. If the difference exists in our dictionary, we found our pair. So, why this works? Basically, the dictionary allows us to search for constant time, reducing the time complexity to O of n, which is super efficient compared to a brute force O of n squared approach. With this approach, we've solved the two-sum problem efficiently in O of n time complexity.